In this video, we're going to talk about function notation. Now, function notation is actually really useful and specific. So most of us have seen at some point, here, let me go ahead and select this pen, this notation, f of x. And you may even think, oh, f of x equals y. Like that's a big thing to say that f of x is the same thing as saying y. So that's function notation that most students have been exposed to at some point. But let's generalize it. Rather than using X and Y, let's use input output. Okay. So this would be f of input. Wow. Started to put output. F of input equals some output. Verbally, if I were to say that, what I'm saying is the output is a function of the input. That's how we are saying that. And then visually we express it as f parentheses input parentheses equals output. And the idea is that the result is the output. It's what comes after that equal sign. It can be written in the reverse direction. That really doesn't matter. But the idea is still the same. Now, we mentioned earlier, input is what we consider the independent variable. The output is the dependent variable. But I also want to add to this that we are going to use some new terminology in the next section, and that's the idea of domain and range. So we're going to give other labels to it. They all mean the same thing. They're all talking about the same group, but that's where we're heading. Okay, let's look at an example with function notation here. So let's introduce function notation to represent a function that takes as input the name of the month and gives the output the number of days in that month. By the way, I didn't type this in here, but we're ignoring leap year for right now. Okay, so leap year is not being included. And if we're not including leap year, then the idea is here, we should give some labels. So M will be month. And that's our input, by the way. D would be days. Right, which they said input, output. Okay, so I could write the function notation two ways. I didn't really have to use the variable labels. I could have just wrote f of month equals days. Oops, that would have been acceptable. Or if I use my little labels, I could have done f of m equals d. Both of those work. Really quick, just to kind of give an example, mainly because they actually said this so specifically, the input as the name of a month, right? Like the name of the month. So the inputs would actually be spelled out. So it would be March, but the outputs would be numbers. So 31, because in March there's 31 days. All right. Let's look at another one. This one, we're told the function n equals f of y, and that represents the number of police officers, that's the n, in a town in a year y. So what does f of 2005 equaling 300 tell us? Okay, so based on the fact that 2005 is corresponding to the year, because that's right there next to the f, in the year 2005, the town had 300 police officers. Pretty big town. Okay, so functions really are represented four different ways. Words, which we definitely seen examples of. Tables, which we did kind of see a little bit at the start. Graphs, we've seen some graphs, and the only thing we haven't really looked at yet is formulas and equations. So let's go ahead and jump into tables now. So what we just looked at were word versions of the function. Let's look at table versions of the function. So which of the following tables represent functions? So this table represents the input number of months. So they actually gave the months numbers. They refer to the numbers and the days, not including leap year. So there I actually stated not including leap year. Okay, so is this a function? And the answer is yes, because each month gets paired with one output only. So each month went to only one output. There's no repeating of those numbers here in the inputs. So this is a function. But let's talk about one-to-one since we've talked about that, even if they didn't ask us. It's not one-to-one because, wow, there are bunches of outputs being repeated, right? So more than input is getting paired with an output, and that makes it not one-to-one. I just selected the number 31, but 30 is repeated a bunch of times too, but 31 is more. Okay, there we go. So that's a function, but not one-to-one. Let's look at another example. This time, they don't tell us what Q and N represent. They use G instead for the function. That's another common function notation. F, G, H are the big three. Okay, it's not limited to those three, but those are the ones we typically see. So I'm looking to make sure for function that our inputs are only going to one output. And yes, it is. It's a function. Again, let's check one-to-one now. It is not the reverse. Darn it. That's 8 and 6, both repeat. So not one-to-one. That's all right. Let's try this one. This table represents the age of children in years and their corresponding heights. Okay, so in this case, it actually fails right off the bat from being a function. You see that? Because we have two 5-year-olds with two different heights. In other words, that 5 is getting mapped to two different outputs. And even though these are individual 5-year-olds, in terms of recording information, if you're talking about children and their heights, two children of the same age could be different heights. Therefore, that input is getting mapped to two outputs. So, not a function. It is, however, one-to-one. In this case, it happens to be one-to-one. That's funny, right? Because we see no repeats there. Not necessarily if they kept doing it, but there we go. Okay, so next video, we'll move on to the next part.